In this module, we will begin looking at how we define the work that needs to be run. In the previous one, we saw how we can identify the unit of work, where in this module we will learn how to code the execute statement to indicate specifically what it is that we want to accomplish. The JCL statement in this case right here is an execute statement. And you can see that again we begin with the // identifying it as a JCL statement. We have a step name. In this case, the step name is optional. However, if there is any JCL coded that will reference a step name or may reference it in the future, then it is highly recommended that a name be provided as a normal matter of coding. The execute statement is the operation field indicating this is an execute JCL statement, and then following that we have a program equals identifying the program we intend to run, and then various parameters that may be associated with that particular program. So the first thing is the step name itself. Again, just like with the job name, we have 1 to 8 characters. These can include national characters in addition to the alphanumeric. And again, as a result, what we need to do is that we need to specify the step name if there's any need for us to potentially be able to reference that particular step. It's normally a good programming practice to code that, unless you're just writing a personal JCL that you know you're not going to be doing anything like that with. But generally speaking, if you're looking at production job streams or you're looking at something that's a little bit more elaborate, you will find that step names are coded as a routine matter of coding. That way, in the event that you need to reference it, if you need to refer to it through a restart, or you have some other sort of override mechanism that you have to invoke, then the step name is already there, and that way you can perform those particular functions. Again, be careful of your installation standards so that in the event that there's some sort of a naming convention that's required or any other rules that govern the setup of the execute statement, you're aware of what those installation standards are. The program equals parameter shows several options here, but for our purposes right now, we're only going to focus on the program equals and then the program name itself. The other two options here are called referbacks, and we will see what the role of those are in a subsequent module. But for the time being, we're going to focus strictly on coding the program name itself that we intend to execute. The idea here then is that when we identify the program to be executed, the system will search for that program in a predefined set of libraries. In the event that the program is not found, the job will just terminate at that point. However, once the program is located, then the program will be loaded and that step will begin to execute. We can also specify a procedure name. Now, procedure names are nothing more than JCL statements that have been stored in a library. So essentially what we have then is that we would have JCL that we have coded, we have stored it in a library, and now we want to execute that JCL that we have saved. In this particular situation then, a JCL procedure is a new term that we have to keep track of that indicates that we have JCL that has been pre-coded, it has been stored in a library, and now we want to dynamically invoke it from the execute statement itself. This will be discussed in much more detail when we look at Module 5. Just as we saw on the job statement, we have a time parameter and the same rules apply. We can specify the CPU time in minutes and seconds. We can specify an unlimited value of 1440 or no limit, or we can specify the maximum value. These are identical to what was on the job statement. Now, the basis for providing them on the execute statement is that on the job statement, those values apply to the entire job. On the execute statement, they only apply to a particular step. So therefore, if we have a job, for example, that might have 5 or 10 steps, then we can selectively determine whether or not we need to specify a time value or a region parameter, as we also had available on the job statement. Again, the same rules apply. This simply defines the amount of virtual storage that we can use, and so in the event that we have some value that needs to be unique to a particular step, we can designate it there. Now, the significance of this is not quite as important as it was in the past. One of the reasons why allowing these parameters to be replicated on the execute statement versus the job statement is that when resources were severely limited, it was important to determine whether you needed to reserve those resources for the duration of the entire job or whether you only needed them for a particular step. And as a result, it was a practice then to try to improve the efficiency of the resources you were using by designating them only where you absolutely needed them. In today's environments, we have significantly larger default values set, and we are not competing for resources in the same way we did in the past. As a result, coding them on the execute statement or on the job statement does not produce any notable differences in behavior. So unless you have something that is extremely unusual, then generally speaking, coding them on the execute statement is just as legitimate a practice as coding them on the job statement. The only qualifier there would be whether or not your installation has any particular standards that require one use over the other. We also have another option here called the parm. Now, the parm allows us to pass data to the program directly from the JCL. So what it amounts to is that these can be like initial values that we might specify or any number of things that a program is coded to receive. The maximum value is 100 characters that we can pass. Now, in this case, the only way you can know what information to pass would be to know specifically what the program is expecting or what the program is capable of checking for. You cannot arbitrarily set parameter values without knowing whether the program is even checking for them or without knowing what the program's needs are with respect to parameter information. An example of this is that sometimes applications were written so that you could pass a date parameter from the JCL. This was often useful as a way of being able to override the current system date so that in the event that you had to rerun or use a previous date or even a future date, you could specify it as a parameter, and that way the program could use that date rather than the current system date for processing purposes. So the program itself is the only thing that can identify what valid parameter values exist. So in the event of IBM programs, this would be documented in the manuals where you will find the programs themselves. In the case of user-written programs, the user must document what valid parameters can be specified and what the formatting requirements are. So these things would all be firmly established by the program itself and whoever the author of that program was in the documentation that they provide.